Example, empty relation, universal relation, trivial relation. All these three forms in one bucket actually. Empty with no elements, universal with all elements, and trivial, both are called trivial actually. I'll explain all this thing in the next few slides, but these three forms in the same bucket. And then we have something called reflexive relation, symmetric relation, transitive relation, and equivalence relation. So these all four also form in one bucket. Correct? So I have actually, this is one type and these are all another type. Now I'll explain all this relation to you. The first is empty relation. As the name suggests, empty means nothing. It has nothing actually, zero element. So if you see the relation R on set A, first before understanding empty relation, I'm just repeating the definition of relation which you have probably learned in class 11, but still I'm repeating it. A relation R on set A is nothing but a subset of Cartesian product A cross A. If you don't know Cartesian product, please go ahead and watch 11th video. So relation R is nothing but a subset of A cross A. So if you have set A and you want to find relation on this, you get this A cross A, and this from this A cross A you take a subset. And that is nothing but a relation R on subset. Similarly, if you talk about two sets and you want to find relation, for example, relation R on two sets. So in the first case, we are talking about only one set. Here we are talking about two sets, set A and B. So if you want to find relation between two sets, actually it is nothing but a subset of Cartesian product of A cross B. Correct? Here you have to find A cross B. Whatever you get set. From this you take a subset, and this is nothing but a relation. This is something we already know. We have learned in class 11. Now what is empty relation? A relation R on set A is called empty relation if no element of A is related to any element of. For example, this guy is 5. I'll give an example, real life. One real life example is these are girls studying in class, let's suppose class 10 in some school, ABC school. Now they are all, let's suppose set A. Set A is nothing but, I'll say set A is nothing but girls of class 10, correct, of ABC school. So it had 1, 2, 3, 4, 5, 6, only 6 girls in this class. Now, if I want to define a relation saying that A is a brother of B, where A and B both belongs to this set. So if I say where I'll say A and B are both member of capital A. Capital A is the set of all the girls in the class 10. Now when I'm saying that this girl is brother of this girl, possible, not possible. So for a brother relation to exist, one male should be there minimum, right? So in this case, with so many girls, we have one set A, for example. Now with this set, if I want to find a Cartesian product, what will I get? 1, 2, 2, or I'll get 1, 3, right? 1, 4, 1, 5, 1, 6. These are the number of the girls. Then with 2, I'll say 2, 3, 2, 4, 2, 5, 2, 6. And then with 3, I'll get 3, 4, 3, 5, 3, 6. And with 4, I'll get 4, 5, 4, 6. And with 5, I'll get 5, 6. I think these many values will get Cartesian product if you take the Cartesian product of this. Now, plus the reverse one also will get. Now the question is, when I say A is brother of B, so I'm saying 1 is the brother of 2, possible, not possible. So this will also not come into our domain, because first thing is we have to take the Cartesian product of this, and then we have to find the one which are relevant. So 2 is brother of 3, no. 1 brother of 4, no. 1 brother of 5, 5. I mean, you'll see none of these are possible, because for a brother relation to exist, at least one guy should be male. So between all these 6 girls, when I say I want to find a relation where A is brother of B, then that relation will have zero element. Why? Because all are girls here. Correct. If I include one guy here, in that case, this won't be empty relation. But in this case, when I'm saying that A is the brother of B, so for a brother relation to exist, at least one guy should be male. So in this case, if you see, there is the relation R will have zero element. Correct? Because you can't find a pair in this and you say that this person is the brother of this. Not possible. Similarly, the same set, if you say, let's suppose I try to create a relation R and I say AB, we'll say difference between age of A and B is 100 years. This will also have zero element, because if you take any two girl, since they are studying in the same class 10, the maximum difference can be 5 or 6 years between any two girls. I'm saying the difference between age of any two girl is 100 years. So in that case also, you won't get any pair where the difference in age is 100 years. So such case will also have zero element. The moment it has zero element, that means that relation is empty relation. Correct? So what I'm trying to say is, you have a set A, set of these girls. Now you want to find a relation. So relation will have these elements, subset of these elements, right? Now when I'm saying the relation should have a property, a pattern, and that pattern is A is brother of B. So with this pattern there is no match. I'm getting zero element. So that relation is called empty relation. Correct? Similarly, for two sets, for example, if you have a set of boys and set of girls also, set A is equal to, let's suppose, set of boys and B is girls, and set B is equal to set of girls, and then also if you create a relationship between them in such a way that there is not even a single element, not even a single pair which match that criteria, then it is called empty relation. I hope this is clear. You take a set of girls, this is one set. From this you try to get the Cartesian product, you get all these values. So if you want to find a relation, you first derive a pattern, and this pattern is A is brother of B. With this pattern there is no match, there is zero match. Since there is zero match, I will say that this relation is empty relation. Had there been a single match also, then this relation would not happen an empty relation. For example, if I say the difference between age of A and B is 1 year instead of 100 years, then there is a possibility that we may find the difference between girl 1 and 2 is 1 year. In that case, the relation may not be empty relation, because it will have some element. For example, this, it will have this element which will fit this criteria. I told a relation should have a pattern of criteria. If even a single object, a single pair fits the criteria, then that relation is not empty relation. Correct? If there is not even a single pair I'm telling because I'm taking only this A and A now, then it is a empty relation. Now let's go.